Chapter 13, number 56. A grandfather clock keeps correct time at sea level. If the clock is taken to the top of a nearby mountain, would you expect it to keep correct time, to run slow, or run fast? And then choose the best explanation from these. So we probably should focus in on what does run slow mean for a clock. And that means that, for instance, in the course of an actual hour, it will show less than an hour. It might show 45 minutes. That's a terribly slow clock, but the idea being that that it will read less time having passed than really passes. But that ends up meaning that the period of the clock must be more. In other words, if the clock goes from, if in so-called real time we go around once, and our clock only goes around 3/4, then for our clock to go around a full time, the original clock must have gone more than. Right? So this is one period on our bad clock, and it's more than one period on our good clock. So we're really saying what happens to the period. But that makes this problem really kind of quick, because the period we know is 2 pi. It's a grandfather clock. It works as a pendulum, so it's 2 pi root L over G. G is the denominator, so if we decrease G, that implies that T gets larger. Making the denominator smaller makes the thing larger. So we have that T of our new place is greater than T of our old place, therefore the clock is running slow. And the reason for that is gravity is weaker at the top of the mountain, so the period is greater.